Welcome to TrailBlazer 1.0, a program made by Caleb Oakes and Dan Jones. This program is really neat. It allows you to chart unexplored paths, or even explored ones. It allows you to digitize your own paths, graphs an elevation view of your trail, which is pretty neat, and it automatically saves your trail as a shapefile to the folder named Data. So you might ask yourself, how do I get this amazing tool? Well, you can download the program here at caleboakes.com/trailblazer_1.0.zip. It will have all the necessary files for the program to run. If you want to view more end-user documentation, download the document at this link. To view more technical and design documentation, download the document at this last link. Now, let's get into the program.
After you've downloaded your TrailBlazer program and unzipped it, you can open it, and there's a shortcut to open the program right here inside the file. Upon opening TrailBlazer, you can maximize it here, and we can see that this is the program as you open it. There's tools, a tool strip up at the top. On the left side over here is all the map layers and the layers that we add as we put them in the map. This section here is the map section, so all the layers will be shown over here. Down here, after you've selected a trail and a DEM, you can graph the elevation and the distance as a cross section down in this section. And down at the bottom, there's also a status bar that shows you how things are going. Especially, this is helpful when you're adding a large DEM. It'll tell you how far along you are. So, the first part of creating a trail map is adding the DEM layer. So, if you go up to the tool strip, you click Add DEM, you can find a DEM layer. There's one included in the data section as a sample. So we add the raster layer, and it pops up in your screen, and it also shows the DEM layer over in the map layers section. And at the bottom, sometimes DEMs take longer to load, and it will tell you how far along the loading is of your DEM down here at the bottom. After you've added your DEM, you can also add a trail shapefile that you have already created by using this link and finding that as well, such as this one. Or you can also go to Trail Tools and digitize your own trail. So when you digitize a trail, it'll start digitizing and it'll pop up a little box telling you how to digitize and how it will end digitizing by double-clicking. So you click OK, and you begin digitizing your line. And you can choose however you like to digitize as long as you double-click at the end. After you've double-clicked, you will be able to name your trail. And this will be the name of the shapefile that the trail is stored under. So you can name it whatever you like. After you've created your shapefile, you can click Trail Tools again and click Graph Elevation, and this tool graphs the most recent trail added to the map, whether it be by adding the trail through Add Layer or digitizing the trail. And you can always go back and open a trail that you digitized. As you can see, Dan Rocks is now also in the data file, and then it will be graphed. So here's the graph down at the bottom. You can see it graphs the elevation in feet and the distance in miles. And so this hike looks pretty rigorous, 250 miles, and pretty tall. But you can zoom in and create a trail that might more match what you're looking for, unless you're looking to cross the United States. A few other tools that we haven't gone over yet. Simple map tools. This pan button changes it so that you're in panning and zooming mode. By clicking the mouse and dragging, you can move the map around, and using a mouse wheel can now zoom in or zoom out. We can also go to select mode, and you can select different trails or different things on the map. and you can switch between the two selection modes. And there's also a help file. You can click the help button and it will walk you through the steps to create a trail and the elevation map of the trail. And that is basically how the program works. And you can exit TrailBlazer by clicking File, Exit TrailBlazer 1.
Alright, let's jump into the code that makes this program run. First, we import all the libraries we'll be using, and then we jump right into our form, which is where all of our code is written. We only have one form. First, we declare all the global variables that we use in more than one function or class. And then in the class FRM main, we initialize components, we load the extensions, which allows zgraph to work and allows you to load DEM formats, and then we apply some initial settings to the graph here, such as distance being in miles on the x-axis, and elevation being in feet on the y-axis. Then we have two buttons, the pan button, if you remember, and the select button. After that, we have the start digitizing button, which is part of a menu. And when that happens, we put the function mode to select. We show the user a message of how to digitize their line. We set digitizing, the global boolean, to true, and then we reset the list of points. The next class we'll cover will be activated on the mouse click event of the main map. Once the user clicks on the main map, it will check to see if the global boolean digitizing is set to true. If it is, it will store any points and convert them to coordinates by using this pixel to projection function and add them to our list of coordinates, my digitized points. The next function we use is called showInputDialog, and it returns a string, and basically it's just a message box that has a text box that allows input from a user, and the input text is called trail name. It has an OK button that will save this and a cancel button, and once the user clicks OK, it will store the input and be able to return that whenever we call that in the future. The next class we use is activated on the event mouse double click of the main map, and it checks to see if we're still digitizing, and if we are, it stops that, and that's how we wrote our code. And then it brings up this input dialog that I just talked about, and the text box is initially blank, and whatever the user puts in there, it stores that as input, as the word input. And then it does a bunch of things. It turns on the pan mode of our map, it saves it as a feature, and it saves that feature in a feature set, and then it projects the feature set to the projection of the main map and adds it to the map so you can see it, and then it saves it in the data folder. You can see that here. Under the data folder, it saves it as whatever the user specified, .shape, SHP. And then it adds that layer to the map and stores it as a line layer, and we'll use that in further analysis.
The next one is when you click on Add Trail Shapefile, we add a layer, which is a map line layer, and we save it as line layer so we can use it later. Basically the same thing happens when you add DEM. You click on it, we add a raster layer instead of a line layer, and we store it inside R. We also reproject it into Not 83, which is in feet, so that we can put the graph in feet and miles. We put it inside a try and a catch because we were doing something with it, and it would throw an exception if it came back null. So we tried and catch it in case they click cancel. This is the main part of the function, which is graphing. So when you click the graph elevation, we go and we get the line layer, which is the trail, and we reproject it, and we get the features, the first feature out of it, which is the line. Then we get the number of line segments, which is NP, by finding the coordinates inside the line and subtracting 1. We also divide each segment into 1,000 pieces in a loop. We chose 1,000 and we set it here, so we could change it if we like, but it seems to work well. Then what we do is we store each coordinate along the line segments inside an X and a Z double array, and so the array is equal to div length times the number of points, or the number of line segments, I suppose. And we have a total length that we set as 0 at the beginning, and we update it later. So this is the first for loop. This loops through each line segment. So what we do is we get the first and the second point, and then we loop through those points until we have the second to last and the last point here. We get the slope of the line along the DEM here, and we also get the total distance between the 2 points in the X direction. We needed an absolute value of that as well, so that we could use it as distance along the graph instead of distance. And A we use for troubleshooting. And inside the other for loop is another for loop for all of the div length segments, so each segment along each line segment. And this goes from 0 to div length. If it's 0, we want to use the actual coordinate 0.1 from up here. So we use the total length at that time, and we get the nearest value from the raster at the point from raster R. If it's not the first point, then we want to get a point along the line, and so what we do is we get the total length plus this distance here is the total distance between the 2 points divided by the number of lengths and plus the distance we've come so far. And then we do total length, which is the total length up to the line segment we're on, plus the distance along that line segment, and convert to miles here. Then with Z, we also get the nearest value from the raster, but we use a little bit of a slope here. This is the distance along the line segment in X, and then Y, we use the slope that we calculated to get the Y. And that's how we get our points along the segment. And then we update total length here, total length plus the distance, so that it's updated every time we get through a line segment. So that's both for loops. After it goes through the entire length of the line, we come down to Z chart, and we clear the list, and then we create a new line that uses X and Z, which are the two arrays that we put all of our coordinates into, and then we add them to the Z graph and update it and refresh it. And that's how we graph the line. Finally, a couple of the last two things. We have a help button, and the help button displays this string, which is here, and it shows the message box. And then if you click the file exit, and we run application exit. And that's the end of the code.
Thanks so much for using our sweet application. Now go hike a mountain.